Hi sir, this is K. Kumar from 3D Department, D section. In this video, my topic is I want to explain about advantages of using the vector magnetic potential when dealing with magnetostatics and time varying fields. Before that, I want to tell you about vector magnetic potential. The vector magnetic potential is defined as the curl of vector magnetic potential is equal to the flux density at any point. Therefore, the curl of A bar is equal to B bar. The advantages. The first advantage is convenience boundary conditions. The vector potential A often has more intuitive boundary conditions and compared to the magnetic field B, particularly when dealing with complex geometries or interfaces between different materials. In problems involving interfaces between different media, boundary conditions on A can be easier to apply, as it does not have the same stringent continuity condition as B. So by using this, we can solve the problems easily. And the second one is simplification in calculating magnetic fields. The vector magnetic potential, typically denoted as A, offer several advantages in both magnetostatics and time varying magnetic fields. And in magnetostatics, the magnetic field B can be derived from the vector potential A using B bar is equals to curl of A bar. And this is a advantageous because it reduces the problem to solve for A and a vector field that typically has fewer constraints that directly solving for B. And for example, in regions with high symmetry or specific boundary conditions, it is often simpler to solve for A rather than B directly, especially since A has a more straightforward expression for current sources, and the compatibility with the Coulomb and Lorentz gauges is by introducing the vector potential A and the scalar potential phi. It is an electric potential. We can gauge choice to simplify Maxwell equations. In magnetostatics, the Coulomb gauge is curl A is equals to 0 is often chosen to simplify calculations in time-varying fields. The Lorentz force gauge, the formula is given here, and this is can be used, which makes A and phi satisfy wave functions that are easier to solve. And gauge freedom can reduce the number of terms and make the equation for a simpler to handle. And the applicability to time varying fields are in the presence of time varying fields, using the vector potential A allows to to relate to the electric field E. The formula is given here, and this formulation is especially helpful when solving for E and B in coupled systems with both magnetic and electric components. Since A is linked to the current distribution, it provides a direct way to incorporate changing current sources and evaluate the resulting time dependent magnetic and electric fields. And the connection to the Aharonov-Bohm effect is, in quantum mechanics, the vector potential A plays a critical role in phenomena like this effect, where the potential influences charged particles even in regions where the magnetic field B is zero. This emphasizes that A contains A bar contains information beyond the B can describe, especially in quantum systems. And the final conclusion is using the vector potential A can simplify many problems in both magnetostatics and time varying electromagnetic fields, especially when dealing with complex geometric time depending sources and the interplay between electric and magnetic fields. So by using vector magnetic potential, it is very easier to solve the problems in both magnetic and time varying fields. So firstly we can revise that concepts. The simplification calculating magnetic field is also simplified by using this method, by using this vector magnetic potential and the convenience boundary conditions. So the boundary conditions will also be simplified and the compatibility with the Coulomb and Lorentz gauges and applying to time varying fields is also very easy by using this potential, which means vector magnetic potential. Thank you, sir.